Okay, time is running, so I better get started. Welcome to this session, which is called 50 Ways to Show Your Data, and it's got the subtitle Condensed Edition. Now, why is that, you may ask? Well, originally, this is a 60-minute talk, and when I submitted here, I learned I had to do a 20-minute talk. So, yeah, the first thing I did was to add 12 more slides to my deck. Makes sense? True story. And then at some point in time, they sent out the speaker's manual. And there was a PDF document, and on page 9, it said in capital letters, you cannot use your computer to do your presentation. And I was like, my demos, I'm stuck. So I had to refactor the whole thing once again, and let's see how that works out. My name is Thomas Hütter, I'm from Germany. I work for a company called Swecon Baumaschinen, and that blue and yellow is not just there to please our hosts. We are actually part of the Landmännen group of company, which is a Swedish group. I work in the IT department as an application developer, and I know a thing or two about SQL Server and the R language. I usually speak at data and SQL events around Europe. You see a couple of them there. So I'll rush you through the agenda. For those of you not familiar with the R language, just a few sentences how it came to be, what's it all about. The philosophy of tidy data, which is a core or concept when using R. And one of those tools that's inside the Tidyverse is the ggplot package. And that is what I'm going to show you how to go about, what you can do with it. So I hope it was clear from the abstract, or now from the agenda, I'm not much of a strategist. I'm a practitioner. I get my hands dirty in code and data every day. So no strategies, no big, we want this, we want that. Just sit back, relax, watch what I have in petto. You don't need to write down anything or take photographs. The important link is on the last slide. Okay? Right. So the R language. How many of you have known or have heard about the R language? Hey, you're all data scientists, are you? Who uses the R language, actually? Okay, a couple of you. So R has been around for quite some time, 1993. The two gentlemen from New Zealand brought it up when they were not satisfied with the S language anymore. It's a GNU project, it's open source. You can have builds for macOS, Linux, Windows. It's freely downloadable. And one key success factor I want to point out is the extensibility through packages. So everyone that's missing functionality can go out and develop a function, make it into a package, and upload it, for example, to the CRAN mirror, so that everybody in the community can use it, can profit from that. And that way, at the moment, there are more than 18,000 packages available for download for the community. There's commercial support. Of course, there has been one example, the Revolution Analytics. They've been acquired by Microsoft and so on. I'm sure Oracle also has R, but I work in a Microsoft shop, so bear with me. So what a typical analytics or data science project may look like is probably like this. You want to import some data, you have to transform it to make some sense of it, to visualize it. Maybe you want to generate some models to get closer insight and then do predictions and all that stuff, take turns transforming, visualizing, and so on. Eventually, you have to communicate it, and all that goes within the bracket of programming. And there's a philosophy of tidy data and a tool set called the Tidyverse. And if you follow that philosophy using those tools, to do all that is very easy, very concise. Once you have the data in the proper shape, there's no need to do transform in between. You just pass it on to the next step in the flow without worrying too much about the format. One part of the Tidyverse is the ggplot package that does the plotting, that does visualizations. It was inspired by the Grammar of Graphics book. And yeah, that's much to say about it, but very simple approach, my simple approach is what you need to build a proper graph. So parameters that go into the ggplot function. The first is, of course, your data. What do you want to show? Second would be the so-called aesthetics. So basically, that boils down to what you want on the x-axis and what on the y-axis. The geometry, you want a scatter plot or a line graph or a bar plot or whatever. And then you got several extras like themes and legends, and you can play around with colors and faceting. You name it, you got it. So this is normally the point where I switch over to the RStudio environment. I hope you can, yeah, there's no need to read all the text in there. On the top left, that's actually the actual demo file I'll be using. And on the bottom right, you see there's a window where the plots appear. You can imagine like calling it step by step and the plots will appear there. You can, of course, zoom in and out and do all that stuff. So, for starters, I'm not going to bore you with too much code, but look at this one. The first 3 lines are there to pull some data from the internet and store it in a variable. I use Formula 1 result data from 2016. Why 2016? Last time a German driver won. So that's the first 3 lines up there. And the next block is to bring the data in shape. There's no column names, you have to add them. I cut it down to I think it's the 9 best drivers. And then I bring it into the tidy long format. And the first approach at a graph looks like this. That's 1 season's worth of results for the best 9 drivers. And all it takes, we'll talk about the quality in a moment, all it takes is that piece of code to build this graphic. And basically, you only need the first 1 to 3 lines, and if you're sparse, you can even put that into 1 line. The bottom 3 are to add labels, add captions, and do a bit prettifying. So that was, all in all, we had like 3, 5, 8, maybe 15 lines of code. Getting the data in, bringing it into shape, and producing a first graph. Now, watch the source code closely. Now, I added about half a line of source code to improve this graphic, and that brings us this one. Yeah? So here is a small subgraph for each driver, so it's very much better to see how they did, but because this is a mess. Although there's only 9 drivers in there, you can't get much out of it. Okay, some other ways to show this data. Box plots, for those of you who are into statistics or even data science, that's nothing new. One simple way of lying with statistics, you see the 2 box plots on the left, the first and second drivers, they look exactly the same, and they are. Although one guy had more points than the other, but that's not in this plot. Or, yeah. If you look a bit closely now, it's probably hard to see from there, the so-called violin plots where you can see the distribution of the points, that Mr. Rosberg had more of the top scoring points than Mr. Hamilton. Okay, who hasn't seen those boring things like black and white bar charts, and you even get the distortion in your eyes from looking at it? There's always ways to improve. Maybe with a lollipop chart. It's effectively called a lollipop chart. So you see, I have no continuing story from A to Z to tell. It's just a collection of charts that can be improved, or someone came up to me and, how do you do it? And that's how we show. In R, there are some built-in data sets. A couple of them deal with car data. So here we have got the mileage over the displacement of some cars, and you see the different colors representing different cylinders of the engine. And there are some 5-cylinder models. You can see that very clearly. Oops, sorry. So they are in the green area, well, encircled area, just to point you there where the action is. This Yeah, the title says it has 234 data points. Just do a quick estimate. What you see is not 234 data points. It's much less. Why is that? Because it's overplotted. Yeah, there are several data XY combinations on the same spot. And what can you do to make that clear? Well, you can either do a jitter, so you lose a bit of the precision, but you see a bit more of the distribution, actually. It's like in the bottom left, there are 5 points in one spot. If you do a jitter, they lose a bit of the exact position, but you see that there are several of them. Or on the right, you can play around with the diameter, where there are more points in one position, the diameter is bigger. Yeah, labeling your points and avoid that the text runs into the point is possible, and also given a color, you can add a third dimension there as well. Yeah, that one I prepared especially for you. We had general elections in Germany last month, but maybe some of you know this. I borrowed it from the Riksdagen, is that right? That's the distribution of the political parties in the Riksdagen. Do I pronounce it right? Probably not. And then with very little effort of coding, you can do this either to count the seats which the parties have, or on the night of the elections, you always go around and checking which coalitions are possible between which parties. And by that way, I learned that the Swedish parliament consists of 8 parties. Okay, tree maps, I'll skip that. That's one example where the community work is really fascinating. You see that large white area down there, it's not there for any purpose. It just, I couldn't get rid of it with my data, and I thought it's probably wrong. So I wrote to the guy who developed the package, and I said, look, this is my data, this is my result. I think that white area, it shouldn't be there. And within 2, maybe 3 weeks, there was a new version on the CRAN mirror, ready for download, and it gave me this. So there's a small white margin on the bottom, that's on purpose there, but the error that it had before was gone. Community work at its best. Okay, correlations, yeah. You can calculate correlations between different measures and visualize them. That goes between +1, -1, you see, blue and red. And that's one way to represent it. And that's another one. So I threw in everything that was possible with this correlation plot, from doing thick lines and thin lines, and the slope up and down, and colors and circles, and even print the values. So that's totally overload, of course. But you could choose from the single ways of representing it to see what works best for you. Okay, so scatter plot. Yeah, that's it. Some scatter plot. You get some data and now ask to analyze it. Can you spot at once where the hot spots are in this one? I can't. So what can you do? Well, there's a thing called marginal plots. You can either have the density line on there, and there you can see it has 2 maximums in the x direction. I wouldn't have spotted that before. Or you can do the marginal histogram all around, or the box plots we saw before, and they even give us the exact position of any outliers. Okay, that's one of my favorites, the radar chart or radar graph. Yeah, the data set is a bit outdated. Who remembers all those cars except for the Volvo? Well, you can approach this from 2 directions. Either you choose a car, let's say we're interested in the Maserati, which is the bright green, and then you can wander around and see where the green line goes. So the green line is top on horsepower, second on displacement, top on number of cylinders, and so on. Or you can do it outside in, let's say horsepower. So you approach it from the outside, horsepower. The first you meet is the green one, so the Maserati is top on horsepower. Next up is the Ford something, Third is the Ferrari, and so on. And also this. No. Also this is done by those, how many are there? 7 lines of code. The cast data set is built in. You do a little bit of transforming, bringing it into shape, and the graph itself is the bottom 3 lines. That's all there is to it. Very simple. Okay, when I do the live demo, I pull some live data over the internet. That's a small German town who publishes the number of free spots in the public car parks. And then you can plot those on a map that's also downloaded in real time. And everywhere where there's a circle, there's a parking lot. The bigger the circle is, the more free places it got. If it's red, it's closed. If it's green, it's open. Animations out, so possible. Oh yeah. Those are the number of cell phone subscriptions, and it shows you the development over time. And it shows that the Nordics, of course, were early adopters of cell phone technology, and then the rest of Europe caught up. Okay, smileys. We all have smileys in social media and so on. There's something called Chernow faces. A guy called Chernow invented these, where you can have the really smiling faces here in green, where the value is positive. So the fuel consumption of a car is good, actually. Or you can have, like down there, the red ones, really frowning faces. That's where the guzzling guzzlers are. 20 liters on 100 kilometers. No good today. Okay, whoops, no, not so fast. Yeah, some more serious things like facet zooming. If you're interested in a small part of your visualization, you could just zoom it out to be on the whole screen width. That's possible in both directions even. And yeah, you can do themes. Like if you have corporate identity, color schemes, and so on, you can add that. If you install a theme, you can just add it with 1 line again to the existing graph, to the existing representation. That's the example how the economist would probably do the work of displaying data. Okay, so usually I would have clicked back and forth between the demo and showed you some more code, but that's not the time. So what I wanted to show you is that even with an open source product like R, and you can download it for free and try it out if you want, a lot is possible in terms of analysis and especially visualizations, of course. The Tidyverse philosophy and the tool set, which is here represented by the ggplot2 package, it helps you to accomplish those tasks in a very concise manner. You always have the part of transforming, tidying your data, bringing it into shape, and then you pass it on to ggplot or any other package that's part of the Tidyverse, and it just uses the data as it comes. But, of course, also in this context, sometimes less is more. Channel faces, not for every occasion. Like if you want to go for a 100 million contract to a bank, you don't want to present your figures with channel faces, right? Okay. So for those of you who want to go home and try it out, the first 2 links are there. You can download it for free, the R and the R Studio, and all the packages are there also. There's some resources that inspired me. Also books, I like reading books on paper, but some of them are online. And the important link is the one down there. If you want to photograph that, that's where this presentation and also the complete demo script will be available. And that leaves me for 40 seconds for Q&A. Any questions in the room? That seems not the case. Any questions out in the country? No. So then I say tack så mycket for your interest and your time, and enjoy the rest of the events. Thank you.
Thank you very much, Thomas. Sir, we don't have any question now, I think, for Thomas, but remember that you have the app, and you can formulate any question in the app, and Thomas will be really glad to answer. And of course, you can approach Thomas because I'm sure that he has triggered your attention with many, many ways to show you data. Thank you very much, Thomas, for your amazing presentation. Thank you.
Thank you.